Okay, welcome to Chapter 6. At Chapter 6, it's titled Finding the Rule. And what it is looking at patterns and trying to find a formula or equation that explains the relationship between, in this case, n and t. But in general, we can just consider it x and y because we've got two different things, an input and an output. So in the first step, the output is 7. In the second step, the output is 12. And so really we can consider these just like points on a graph. 1, 7, 2, 12. And we can graph these on our graph. 1, 2, 3, 4, 5, 6, 7. We can go to 2, 12. We can go to 3 and 17. And now I can't draw a straight line on this because I haven't figured this program out. But if you connect these dots, this is a straight line. It's because every time you go over one space, you go up the same height. And so in this case, every time you go over 1, you go up 5. Over 1, up 5. Over 1, up 5. And so you have that constant slope, keeping the relationship the same. Okay, so we can write this formula as y equals mx plus b, and all we need to do for every single problem in this section is find out what is the slope and what is the y-intercept. Okay, I'm just going to clear this and work this problem out as if we were doing a problem from, a few weeks ago where we wanted to find the slope and y-intercept. Okay, now there's two ways to do this. There's looking at it in terms of y equals mx plus b, and then there's the way the book does it, which is maybe just a little bit easier, but it's the same either way. So what you're going to do is you're going to say, okay, well, the slope, let's take this as 2 points, and you won't have to do this on every problem, but just for the first one, let's consider this 2 points. So the slope, m, equals y2 minus y1 over x2 minus x1. Again, I'm only doing this once just to show you. You get 12 minus 7 over, and then 2 minus 1, which is 5 over 1, which is equal to 5. And so a much shorter way of seeing this is every time we go over one space in terms of x, so every time we go from 1 to 2, from 2 to 3, from 3 to 4, what is y going up by? And in each step, it's going up by 5. So as x goes up by 1, y goes up by 5. Next, y goes up by 5, x goes up by 1. So in other words, the rise, or y increase, over the run, will always just be this number that is getting added each step. Okay, so just to clear this off, on a normal problem, what this would look like is you would have the increase being 5 between each step. And so you would say, okay, my equation is for sure y equals the slope times x plus something. And then you just have to figure out what the y-intercept is. Now, if their chart here, if your t-table starts with 1, it's really easy. You just go back a step and say, okay, well, what would it be if we were looking for 0? Well, if it went up by 5, up by 5, up by 5, well, we just have to go down by 5. So 7 minus 5 is 2. So in this case, the equation is y equals 5x plus 2. And that's the entire question, okay? Now, this gets a little more difficult if you have a table of x and y's where it doesn't start at 1. Let's say it starts at 8, 9, 10, and let's say it's 100, 103, 106. Okay, so each time it's going up by 3 and going up by 1. So we say, oh, okay, this is going to be y equals 3x plus something. But it's not easy to go back to 7, then 6, then 5, then 4, all the way back, and 3, and 2, and 1, and 0. And so this method doesn't always work. But most of the charts on your homework will be similar to number 14 up here, which is a problem out of 6.1. And we'll start with 1. So all you have to do is go back one step to 0. So minus that 5, and you have your y-intercept. So that'll help you with a lot of problems on the homework. Now I'll show you the way that the book does it, which is really the same with one little caveat. So now, this problem is very similar. We notice right away that every time we go up 1 over here, we go up by 2. And then the next one, we go up by 2. The next one, we go up by 2. So our slope is going to be 2. And our formula is going to be y equals 2x plus something. In this case, again, it's really easy. You can go back from 0 and say, or back to 0 and say, well, what is our y-intercept that we started at then? Our y-intercept here will be 4. And we can know that this is going to be 4, and our answer is y equals 2x plus 4. Again, if we don't start at 1 up here, it's going to be a little more difficult. So the way the book does it is they say, all right, let's take this table and just expand it a little bit. Okay, so we have our n, which represents our x, or our input. We have our, I wrote over it, I believe t, which stands for our y, or our output. And they go, okay, so we've got 1, 2, 3, 4, 5. And we know our output is 6, 8, 10, 12, and 14. And they say, well, we know that we're going up by 2 each time. We know our slope is 2. We know our formula is 2x plus something. And so let's start with that 2x. And let's say, okay, well, what is 2x equal to? Or 2n, okay, or 2x, same thing. Okay, so we get 2 times 1 is 2. 2 times 2 is 4, and 6, and 8, and 10. And then what it says is, okay, well, we know our slope is 2n. We know our formula is 2n plus something, or 2x plus something. So what do we have to add to 2 to get to 6? Okay, plus 4. Again, let's check it on another one. 6 plus what is equal to 10 plus 4. So, oh, our formula is this column plus 4. So again, it's 2n plus 4. So regardless of which method you use, going back to 0, as we did up here in the top. So if you go back to 0 to find your y-intercept, you get 4. Or if you make this extra column like the book does, you will also find the same thing. So either way, you're getting that formula, y equals 2x plus 4, the nice linear relationship which all of you can graph. And this is just another way to get comfortable with the same thing, okay? Okay, next, they start applying this to patterns. So just line out matches in triangles. They start the table off here for you. I will do it, let's do it with the y equals mx plus b way. Okay? So you start your table off, you've got T and M, T standing for triangles, 1 triangle, 2, 3, and 4, and then it would keep going. And then you've got matches, so 3, 5, and we're going to have to figure out the rest, so we can go up here to this third diagram that has 3 triangles, and we can count how many matches, 1, 2, 3, 4, 5, 6, 7, so this would be 7. And then we go to the next one with 4 triangles. We go 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and obviously you see the pattern happening here. So this goes up by 2, up by 2, up by 2, and we know our slope is 2. So the formula is y equals 2x plus something. Okay, so you could see, okay, well, what do we have to do? 2 times 1 is 2 plus, and we can see, oh yeah, we have to add 1 to that to get to 3. Or you can take that step backwards and say, what was our 0 step? What's our y-intercept? So going back, 2, we get 1 as our y-intercept, okay? So multiple methods to get that extra number, but either way, we're going to come out with y equals 2x plus 1. Now, to be completely correct, you should just use the letters that they gave you. So our input, or our x, was t for a number of triangles, so 2t plus 1, and I always put this tail on my t's so it doesn't look like a plus sign. Okay, so I put that big T tail, so I know it doesn't, like, kind of like a backwards J, so I don't get confused with like a plus plus. Okay, and that's equal to our y, or our output, which in this case was matches, or m. Okay, and so that's going to be m equals 2t plus 1, or y equals 2x plus 1. Both totally acceptable on a test or quiz. And then just to do one more word problem, because I know word problems are always the scariest things for math students. Let's just set this up. Again, you just need to get your x and your y and set up a table. Okay, so we need our table, again, with this being our x, this being our y. In this case, we have either the triangles t or the squares s to choose from. Okay, so let's count each one. I'll do our triangles in red. So number of triangles in this first one is 1. Triangles in the second one is 1, 2. Okay, triangles in the third one are 1, 2, 3. So this is probably going to be our x because it goes 1, 2, 3. And the next one goes 4. Okay, so I'm going to go ahead and put that as x because it's got our 1, our 2, our 3, and our 4. All right, you could write this either way, as it just says a formula connecting t and s. It doesn't say the words, the formula for t in terms of. It just says to connect the two. So honestly, it could be either way. All right, now let's go ahead and count how many squares there are. 1, 2, 3. Okay, 1, 2, 3, 4. 1, 2, 3, 4, 5. Obviously, you see the pattern. And this one, there's 6. So it's 3, 4, 5, 6. All right. So after we just translated that into a table here, and just know that our letters that we're using is triangles for t and s for squares. And some of you might have noticed, again, math is really about simplifying things and just making it as easy as possible. Just what it's really asking is, what's the perimeter of these triangles, right? Because one square is on each side, so the perimeter there is 3. Perimeter here is 1, 2, 3, 4. So there's 4 squares, one on each side that points out. In other words, you add up the 4 squares, you're saying there are 4 sides facing outwards. Again, nothing to do with the problem, just showing you how to think mathematically and see there's 5 spaces here because there's 2 on the bottom, so 5 squares. It's just asking the perimeter. All right, so back to the problem. Let's get the equation for this. Each time you go up 1 on the left, you go up 1 on the right. So this is going to be y equals, the slope is 1x plus something. And how do we get that something? We got 2 different ways. Let's go back from 1 to 0. And what is the y-intercept? Minus 1 from 3, and we get 2. So, y-intercept of 2. And let's just double check that. It's always great to double check your work, especially if you're on a test or a quiz. Let's just plug this in and see if it works. 6 for y equals 1 times 4 for x plus 2. Okay, well that's 6 equals 4 plus 2, which is 6 equals 6, and what? So exciting. We've got the formula. Okay, so you can write it in 2 ways. You got y equals 1x, which is, of course, just x plus 2. Or you got y equals, just to write it with the correct variables, y was our squares. So we've got squares equals. And then x was our triangles, so t plus 2. Okay, now both of these are absolutely correct. But when you look at the back of the book for answers, or you're answering a word problem, it's best to use the letters that they gave you at the beginning, even though you did find the correct relationship. All right, well, in class, we're going to do some homework problems and work in partners, and I hope you guys will be super successful with this. Good luck.